So hello everyone. So in this video, I am going to concentrate on KCET numericals and capacitance of parallel plate capacitor. Okay. So see the first question. M and N are the plates of unequal areas of the parallel plate capacitor. Let AN and A2 be the areas of M and N. Let A1 is greater than A2. M and N are the connected to the positive and negative terminals of the battery respectively. If Q plus and Q minus are the charges on the plates of M and N respectively, then what is the charge value they have given? Okay. So what they are given? So they are given two plates. So let its name is M and this name is N. Okay. So and it has unequal areas. So unequal areas they have given. So here they have given A1 is greater than A2. I will consider this one as A1 and this is A2. So this is A1 is greater than A2. Okay. M and respectively. Then so M and N are connected to the positive and negative terminal respectively. M is connected to the positive and N is connected to the negative terminal. And here, so Q plus is the charges on the M and Q minus is the charges on the N. Okay. So if this is positive charge means here there is an accumulation of all the positive charge, and here there is an accumulation of negative charges. Okay. See, this longer terminal represents the positive charge and shorter terminal represents the negative charges. So since this is positive charge, so this is also positive charges, it will repel each other. Okay. So here also, so this is also negative charge and here also negative charges, it will also repel each other. Okay. So what happens here, the quantity or the magnitude of the charges repelling here from the M, so that is equal to the magnitude of the charges which is repelled by the plate N. Okay. So that's why, so charges becomes Q plus is equal to Q minus. Okay. So this is the answer. So see the next question. A parallel plate capacitor has a capacity C if a thin metal plate M join the two coatings of A and B of the capacitor, its new capacitance is. Okay. So what they are given? They are given the two parallel plate capacitor and they are given a thin metal with joins the A and B. We need to calculate the new capacitance value. C dash is equal to question mark. Okay. So here, since this thin metallic plate joins the A and B, the potential becomes same. Okay. So the potential from A and B becomes same and its potential difference becomes V is equal to 0. Okay. If I want to calculate the capacitance of the capacitor, so I need to use the formula C is equal to Q divided by V. C is equal to Q divided by V value is 0. Okay. So anything by 0 means the answer is infinity. So see now next numerical is a parallel plate capacitor of capacitance 5 microfarad is charged to 120 volt and then connected to the another uncharged capacitor. If the potential falls to the 40 volt, the capacitance of the second capacitor is. Okay. So what is the question they are asking? Here we need to calculate the capacitance of second capacitor. Okay. So what is the data? The parallel plate capacitor of capacitance. Here initially they have given the parallel plate capacitor and it is connected to the potential. So its V value is 120 and this one is 5 microfarad and then it is connected and it's connected to the another uncharged. So here they have connected to the another uncharged volt and here but the potential drops to the 40 volt. So this is, so I will call this one is C1 and this has C2. So here I need to calculate C2. Okay. So it is equal to question mark. Okay. So this is the required data. Okay. So in order to calculate the C, so what is the C formula? C is equal to Q divided by V. Okay. So I want Q. So Q means, so in order to calculate the Q becomes C into V. Okay. So Q becomes C into V. So that is equal to, what is the Q value? So C value 5 micro is 10 to the power of minus 6 into V is 120 volt. Okay. So here 12 5 is 60, 10 into 10 power minus 6. This can also be written as 600 microfarad. Okay. So this is the charge value. Now, so this one is charge value. In order to calculate the C2, again I will use this only. Okay. Now, so Q is equal to here, so C into V, but instead of C I need to calculate, so C1 plus C2. Why? Because it is connected to the C here and then connected to the another uncharged. It has not detached. Okay, it is connected. So that's why I will use C1 and C2 into V. Okay. So what is the Q value? So Q value we got, So 600 microfarad. I will put the answer in micro only. So C1 plus C2. So C1 is 5 microfarad. So plus C2 I need to calculate into V. So what is V value? So V is 40. Okay, simplify this one. Here 600, so divided by 40 is equal to 5 plus C2. Here 0 cancel. 4 ones are 4. So 4 5s are 20. Okay, so 15 is equal to 15 plus C2. So here it will become 15 minus 5 is equal to C2 and 10 is equal to C2. Okay, so answer becomes 10 microfarad. Okay, so 10 microfarad is the required solution. So see now, next numerical is the potential of two plates of a capacitor are 10 volt and minus 10 volt. The charge on the one of the plate is 40 coulomb. The capacitance of the capacitor is, okay. So what they are given, the potential of the two plates of the capacitor. Okay, here they have given the potential difference. So that is, so 10 minus of minus 10. Okay, it will become 20 volt. Okay, na? So potential becomes, so 20 volt. The charge on one of the plate, so charge value is, so 40 coulomb. The capacitance of the capacitor C is equal to question mark. Okay, very simple question. So C is equal to Q divided by V. What is Q value? Q value is 40 divided by V value is 20. Here 0 cancel, 2 ones are 2 2s are. So 2 farad. So 2 farad is the answer. Okay. So next question, what are the factors affecting the capacitance of the capacitor? See, capacitance of the parallel plate capacitor is given by C is equal to A epsilon naught divided by D. Okay, so where A is the area of the plate and epsilon naught is the permittivity of the free space or the dielectric medium between the two plates, and D is the separation between the two plates. Okay, so that's why the answer is, so both B and D. Okay.